Okay, so this is integration by parts, question 3C. I think it's topic 3.4. So you want the integral of e to the power of y cos squared y dy. This is quite a bananas integral, so if you or anybody in YouTube land has a nicer, faster way of doing it, that'd be brilliant. But we're going to try do it by parts in any case. So just let me talk us through our choice of u here. So the first thing we notice that's different is we've got a cos squared y in this case. So let's just say I let u equals to cos squared y. Now, as I said before, that's just the cos of y all to be squared. Now, that is a chain rule. So in the chain rule, du dy, I bring my 2 down in front to multiply. So it's 2 times the cos of y. And then I multiply that by the derivative of what's inside. And the derivative of cosine here is going to be minus sine of y. So that leaves me, when I just reorder it, I bring my minus to the front. Minus 2 cos of y sine of y. Now there's perhaps a way to keep going with this, but choosing this as u kind of leaves me with something quite complex that when I have to try and integrate later causes a few problems. So my suggestion is that instead we use e to the power of y as our u. So I'll reset this and I'll get ready to go. Let my u equals e to the power of y, so du dy equals e to the power of y. So du is equal to e to the power of y dy. And in this case, I'm going to let my dv equals to cos squared of y. Now, inside in your table book, your formula book, looking for the derivative of cos squared. So if you check out your formula book, you'll see the derivative of cos squared x, will be a half times x plus a half sine 2x. Okay, so that's the integral we're going to use. So check out your formula book, see if you could just identify that. But of course we're not using x here, we're using y. So the integral of dv in this case is equal to a half times y plus a half sine of 2y. So my integral of dv is of course v. So v is a half times y plus a half times the sine of 2y. Now what I'm going to do is I'm going to multiply my half in just to make things a little easier to look at. So my half comes in, a half by y is y over 2. And a half by a half of a half is a quarter of sine of 2y. Okay. So v is equal to y over 2 plus, and remember I said before I could treat the sine 2y as if it's over 1. So fractions multiplying top by top, bottom by bottom, that'll just be sine 2y over 4. Now we'll probably end up stripping the 2 back out of that later, but it's just a little easier to look at for the moment. So I have my 4 important parts: u, du, dv, and v. So let's now try and do our integration by parts. So our formula is u dv is equal to uv minus the integral of v du. Now it's going to be quite a long integral, so you're going to have to stay with me, and I'd even take a few breaks as you're doing it. So the integral of u dv is what they're asking me to differentiate or to integrate, which is e to the power of y cos squared of y. That's equal to u times v. So u is e to the power of y, and this is my v here. So u is e to the power of y times y over 2 plus sine 2y over 4. Now, I'll tell you what I might do. I'll keep going. Minus my integral of v du. So v in this case is y over 2 plus sine 2y times 4, and I multiply that by du, and du is e to the power of y. So I'm just going to put the e to the power of y in front because it's a little easier to look at. So it's e to the power of y times y over 2 plus sine of 2y over 4 dy. Okay, so yeah, I might consolidate my fractions here before I go any further to make things just a little easier to look at. So I've got my y over 2 plus sine of 2y. So what I'm going to do is I'm going to get a common denominator first. So just to remind you, if I had a half and I was adding on, if I had a half and I was adding 3/4, I'd need a common denominator. Obviously 2 and 4 both go into 4. So if I multiply this denominator by 2, I have to multiply the numerator by 2. So 2 times 1 is 2. And I'm not changing this denominator, so the 3 gets to stay as it is. So that would be 2 plus 3 over 4. And I'm going to apply the same principle just for simplifying this, just to make it a little easier to look at. I've got 2 and a 4 again, so my common denominator will be 4. So this common denominator gets multiplied by 2 to make it 4. So I also have to multiply the numerator by 2. 2 times y is 2y. But of course the sine 2y is still over 4. So that can stay the same. That just might make things a little bit easier to look at up here. So rewriting this, I've got e to the power of y multiplied by 2y plus sine 2y over 4. I'll leave that, I don't want to mess with that. I can change that at the end if I need to. Minus the integral of e to the power of y times 2y plus sine 2y over 4 dy. Okay, so tidying up a little bit more, multiplying my e to the power of y into my brackets, e to the power of y 2y plus e to the power of y sine 2y all over 4. Minus the integral of, and again I'll multiply my e to the power of y in here, e to the power of y 2y plus sine, e to the power of y sine 2y all over 4 dy. Okay, so I see I've got a little bit of a complicated integral here to work out, but what I might do is, because the 4 is dividing everything, I might just pop it out in front to make everything easier to look at. So I've got e to the power of y 2y plus e to the power of y sine 2y all over 4. And then I bring my 4 out in front, so I've got minus 1 over 4. The 4 is dividing, that's the same as multiplying by a quarter, of e to the power of y 2y plus e to the power of y sine 2y dy. Okay, so I'm going to focus on this for the moment. This integral in here, it's quite complicated. So we've got to integrate this part here and this part here. They're separate. They're separate expressions. So I can treat them as their own individual integrals. So what I mean by that is I can just have that as the integral of e to the power of y 2y plus the integral of e to the power of y sine 2y. So I have two separate integrals. Now you want to take a breath here because now it gets quite complex.